Good morning, Year 11. It's currently 8:45 a.m. and I'm just recording a couple of example questions for you guys, just in case you're struggling with some of the questions from the relative frequency chapter that we're doing today. Oh, this is Mr. Govan, by the way, just if you didn't recognize the dulcet tones. I'm in the science lab at the moment, so we're crossing to you from the science lab, and I'm going to do question 2 from exercise 5F. You guys don't have to do this one, but this is just an example of how we would do a relative frequency table. So enough chatter, let's get to it. Question 2 says that the frequency table shows the outcomes of an experiment. What is the relative frequency for the following outcomes? Answer correct to 3 decimal places. All right, so A, we're asked, what is the relative frequency for the outcome HH? So if we have a look at our table, we can see the outcome HH is at the top here. I don't want to configure my pen, thank you, Windows. The outcome HH is right here. And then our frequency for HH is going to be 8. So our formula that we're using for this whole entire topic is going to be relative frequency equals F over N. And F is the frequency of the value, so that's what we've got here. F equals 8, straight from the table. And then N is going to be the total number of outcomes. So if we have a look at our table, the way we work out the total number of outcomes, N, is going to be adding up all the frequencies from our table. So we'll take 8 plus 20 plus 28 plus 12. All these values are just coming straight from the table. And this is going to equal 28 plus 28, gives us 56 plus 12 is going to be 68. Really should have brought a calculator with me, but there you go. So then our relative frequency, which is what we want to find for HH, is going to be 8 over 68. So that's pretty simple. Then we just need to simplify that fraction, which I can't do in my head, but I'm sure you guys will have a calculator on hand to use. Let's do part B as well, just so we're sure that we have this down pat. HT, our outcome for HT, is going to be F for HT is 20. That comes straight from the table again. And then our N is going to be the same once again, 68, because it's from the same experiment. So this time we'll have 20 on 68. And that's our frequency for part B. So you can see these relative frequency problems are not too difficult. Should be pretty straightforward if we follow that same method for all of the experiments. We're going to look now at question 8 from your textbook. This is a question on simulations, and this one might be a little bit more difficult to understand if we haven't seen it before. So we're going to go over to, actually, we'll read the question first. Question 8, perform a simulation to determine the winner of an election. There are 4 candidates, A, B, C, and D, and each candidate is equally likely to win. So the first thing that we need to know is, if we have 4 candidates, A, B, C, and D, and they're equally likely to win, that means that of these 4, there's a 25% chance for all of them, because this is how we add up to 100% while they're all being equal. And then 25% translates to 1 over 4. So this is important for what we're going to do next. Part A says, use the random number function on a calculator or toss 2 coins for this simulation. Assign each candidate a result obtained from the simulation. All right, so I'm just checking whether I'm recording now. I hope that I am. Well, it seems like there's a little icon there. All right, sorry, hopefully that wasn't too massive of an introduction. Maybe you could have gone and got a drink, paused and got a drink while I was doing that. Performing a simulation to determine the winner of an election, there are 4 candidates and each candidate is equally likely to win. All right. We're going to use the random number function on a calculator or toss 2 coins for this simulation. Assign each candidate a result obtained from the simulation. So this is going to be quite difficult because you guys are going to have your calculators at home and you're not going to be able to, we're going to have to compare between my Excel spreadsheet. We're going to use the program that I know you all love so much, Excel, just because it has a random number function exactly the same way as a calculator. But for you guys, you'll just be able to punch in that random number on your calculator and that'll give you the same result as what I'm getting from Excel. So what it says is assign each candidate a result obtained from the simulation. So what our random number function does, oh, that's a bad hash. All right, random number is going to give you a number between 0 and 1, any random number between 0 and 1. So it'll have a certain number of decimal places and it'll just spit out a fully random number. What's really good for that is that we can use this to simulate probabilities of events. If we set up the random number to be 25% per probability. Now, the way we're going to do that is for each of these outcomes of the election, A, B, C, and D, we can see that we have a 1/4 chance. And we're going to take this number 4, because there's 4 outcomes, and each one has a 1/4 chance, and we're going to do random number times 4. And what that's going to do is, that'll spit out now a random number between 0 and 4. So when we get that random number spit out, what we're going to do is we're going to assign some of these values between 0 and 4 to each of our candidates. So let's say that if the number comes back to be between 0 and 1, we're going to consider that candidate A. If the number comes back between that's wrong. Let's see if I can work out how to rub that out. Oh, I'm a genius. Okay. If the random number comes back between 1 and 2, we're going to consider that to be candidate B. Between 2 and 3 is going to be candidate C. And between 3 and 4 is going to be candidate D. And you can see that because of the way we set this up in times by 4, there's going to be an equal chance of getting between 0 and 1, 1 and 2, 2 and 3, and 3 and 4, because we're getting a random number each time and multiplying it by 4. So that means we're going to end up with a 25% chance of getting each of these outcomes. So let's swap over to Excel. And in here, I'm going to have to flip my laptop over. In the top here, I'm going to write equals random number, there it is right there, times 4. And the way that you guys would do this, if you're doing it on your calculator, is you just press the random number button on your calculator and then put times 4 and then hit equals. So I'm going to hit enter there, and we've got a value that's 2.83. So that means that this one lies in between 2 and 3. So we've got a value for C there for our probability. So that means in this particular trial of one event, candidate C was randomly chosen to win. Now, this simulation asks us to complete 148 trials. So for you guys, what you'll do is you'll just hit equals again on your calculator, and the number will change this time to 3.1, and that means that this time candidate D has won the election. So what you're going to have to do is do that 148 times, which is a bit of a pain, but that's maths. On this right-hand side, what we're going to say is candidate C, sorry, we'll do it in order, A, B, C, D, and I'll make this lowercase just so we, you can see every time I'm inputting a value or changing a cell that this random number keeps changing because we're, it's just assigning a random number each time to what I'm doing. All right, so we got, for our first one, we got C. So we'll put like a, let's say a tally in here. This is how you guys would do it. Let's put a tally point in here and a tally for D. And then I'd keep continuing this 148 times until we did all 148 trials of the simulation. Now I'm just going to get rid of this for a second. And because we have the magic of computers, I'm going to pull down my values right down to 148. I think I started a couple of cells down, so I'll go down to like 150. And you can see now that I have a whole bunch of random numbers, and we can see that they're going to end up corresponding. It's going to change every time. Well, that's a little bit unfortunate. But obviously, if I had all of these numbers here, I could go somewhere over here and I could tally up every time there was a number that started with 2, then that's going to be candidate 3. Oh, sorry, C, because that's between 2 and 3. Any number that starts with 3 is going to end up being candidate D. Any number that starts with 1 is going to be candidate B. And any number that starts with 0 is going to be candidate A. And so then we record our entire frequency table. So obviously that's going to take 148 tallies. So I'll leave it here with you guys to finish the rest of this question. And you're going to create a frequency table and calculate the relative frequency just the same as we've done for the frequency tables that are written in your book. You're just creating the frequency table this time by performing a simulation. So how do I stop this from recording? I don't know. Here we go.